This is a simple walkthrough on how you would measure the flatness of a granite table. The first thing I would do is take all the bits out of the boxes, put them on the table and connect them all up and let them settle. The Talyvel is a delicate instrument and there is a clamping knob on the side which needs to be done up during transport and unclamped for measurement. On the old Talyvels, the clamping mechanism was the two knobs at the top. The Talyvel is a pendulum device hanging freely between two halves of a coil. As the Talyvel tilts, the position of this pendulum changes within the coil, and it's this that is measured by the Talyvel. We're ready to start a measurement now, and the first thing is to switch the level on and choose whether you are using the USB cable or wireless option. Assuming all is correctly set, this is the screen you should now be seeing. Before starting to measure, make sure the table is level in both directions to within about 30 seconds. Now some tips on the granite table itself. First of all, check that the table is stable. The best way to do this is to walk round the table and see if the Talyvel meter moves. Or put a weight on the table about the same size as a Talyvel and see if that changes the level itself. Fluids. Make sure that people are using the correct cleaning fluids. Granite is porous like a sponge. If you spill any fluid on it, it will soak it up and that will change the shape of the table. And finally, temperature. Make sure there are no great temperature gradients. For example, there are no fans nearby or no heaters nearby. There are various options on the software, but we'll be looking at flatness. That's Union Jack flatness and the grid pattern. The software is very intuitive and easy to use, has simple guides that steps the operator through the measurement. So let's start to measure flatness. The first thing we have to do is determine the size of the table and then how many points per line we're going to need. When measuring the table size, we have to take about an inch off the edge because of the feet on the adjustable base. So the software now knows the size of the table and knows how many points per line you need. So the software will now tell you what to set your adjustable base to. There is some adjustment for tilt on the adjustable base, so you can actually zero the Talyvel before you start your measurements. To ensure that we move the Talyvel in a straight line, I tend to use some kind of straight edge. The simplest for us to use is something like an aluminium extrusion, which is readily found and quite light. For the Union Jack, there are 8 separate lines to measure, and you can measure these lines in any order. But the direction is important. The direction A to B is different to the direction B to A. When you have completed your measurement, you get 3 sets of results. First of all, the isometric plot, showing you the lowest point at 0. Then you get a certificate with the highest point underlined, and you will also see some zeros on this one. And finally, a table of results showing the raw data converted to height and also giving you the closing error. Now let's talk about what the closing error is. The closing error is a useful indication on how accurate you've made your measurement. As a rule of thumb, I like this value to be less than 10% of the total flatness. Now to explain exactly what closing error is a little more difficult. Basically, the software measures the 4 outside lines first, then it will measure the 2 diagonals. The software will then draw in the cross, EG and HF. The closing error is where the crossing point of the diagonals misses the line EG and misses the line HF. We can also offer a twin level system or a differential system. This is where one of the levels is used to monitor any vibration. You can also use an autocollimator to measure flatness using the Union Jack, but this is a little more difficult and complicated than using a Talyvel. We can also offer the grid pattern. Some people prefer the grid pattern because it gives you more data density. It gives you more data on the actual table. This is especially important on large tables. The grid pattern program is very similar to the Union Jack program, with the exception of the reversal. This is important because we have to reference the measurement to gravity. Hence we must reverse the Talyvel, measure it in one direction, turn it around 180 degrees and measure it in the other direction. Then an error correction is applied. Now because the grid pattern must be referenced to gravity, you unfortunately cannot use an autocollimator to measure flatness with this pattern. If you need any more help in the measurement of flatness, please contact Spectrum Metrology directly. Thank you.